All right, welcome back. So we're going to take a look at vertical asymptotes now. So I just have a little intro to this. We've got our rational function right here. Here's a graph. And what I'm wondering is, what do we have at x equals 3? So if we're looking at the x-axis here, sorry, at -3. Okay, what do you notice that is? We do have a vertical asymptote at x equals -3. So I want you to take a second, maybe pause the video and think about looking at the equation and looking at the graph and knowing it's a vertical asymptote. How might we be able to find the vertical asymptote algebraically? Okay. So if you haven't guessed it, right? Essentially what we're doing is setting our denominator equal to 0, because if you look here, right, if you take your denominator and you set it equal to 0, it's going to be undefined. You can't have, it's undefined, there's no value. So whatever value makes this denominator undefined is not going to exist here, right, because it can't. And so if you solve, what you'll get is a vertical asymptote at x equals 3, okay? So that's the basic idea behind vertical asymptotes. We're setting our denominator equal to 0, and we are solving for x. Okay, so in this first example, take our denominator, set it equals 0, and this solve for x. That would be our vertical asymptote. Okay, same thing here, set this equal to 0. Now it's already factored for you, so you can go ahead and set each of the factors individually equal to 0. And solve that way. -1, +5. And we'd have 2 vertical asymptotes, which is fine. You can have as many vertical asymptotes as you want. Okay? And then, again, you're setting this equal to 0 and solving. So we're going to have to factor this. -8 and -2. So 2 numbers that multiply to give us -8. But add to give us -2, probably -4 and 2. And again, we're setting both equal to 0 and solving. Our 2 asymptotes will be 4 and -2. Okay? That's vertical asymptotes. The last piece we have to look at are holes. Okay, so if you take a look here, a hole, as a reminder, is just a discontinuity. It's just a point in the graph that does not exist because it's been removed. Okay, so remember, we're literally taking out this piece and flicking it away, right? So here's our function. I've actually factored it for us. Okay, what do we have at x equals 3 and x equals -2? Okay, so you can pause the video and take a minute to think about it, but at x equals 3, that's right here, we have a vertical asymptote. Okay. At x equals -2, what do you notice? Right, we've got a hole. Okay. So now I want you to take a second. I want you to pause the video and think about this next thing. I want you to think about looking at the equation, looking at the graph, and knowing what we have at where. How might we be able to find the vertical asymptote? Right? And we already kind of know how to do that, so think about it. And more importantly, where's the hole? Okay, because again, remember, we're taking a piece of the function, literally pulling it out and removing it. Okay, so pause and think about it for a second. When you feel ready, unpause it. Okay. So if you haven't guessed it, the hole is hiding wherever you have a canceled factor. So if you notice here, you've got the same factor in the numerator and the denominator. Okay, and so what happens is those actually cancel out with each other, right? You can cancel those out mathematically, and what you're left with is x minus 1 over x minus 3. Okay, so this right here is your simplified function. Totally simplified, which is great. We like simplified functions. We want to use our simplified function always to find vertical asymptotes. Okay? And that's why, right, we take our x minus 3 in our denominator, set it equal to 0, and bam, we've got our vertical asymptote at x equals 3. That's what we thought. But what about our hole? Where did that go? Well, remember, a whole is just us literally taking a piece of the function and flicking it away, right? And so algebraically, what we did is when we canceled these two factors, we literally took a piece of the function and flicked it away, okay? So in order to find your wholes, okay, obviously you need a factor first, which we already was done for you. Whichever factors cancel, those are the factors you are setting equal to 0 and solving for, okay? So up here, it was x plus 2. So if I wanted to find my whole, I'd take x plus 2 and set it equal to 0 and solve, right? This is just the x coordinate, though, okay? A whole is a coordinate point, right? This is an actual coordinate point. Okay, so if this is just the x value, how am I supposed to find the y? Right? Well, if you use your original function, you're going to get 0 over 0 because you still have that factor in there. So what you need to do is use your simplified function here to find the y value. So this is just the x value. We need to find f of negative 2 using our simplified function. So negative 2 minus 1 for negative 2 minus 3. This becomes negative 3 over negative 5, which becomes 3/5. And I would say this is our whole. And you can write it as a coordinate point as well. Okay? So wholes and vertical asymptotes can get jumbled up together. So just make sure that you're following these steps right here. Factor any cancel. Now, if no factors cancel, that means you don't have a whole. That's fine, okay? But in this case, we're going to have some factors that cancel. We're going to take those canceled factors and set them equal to 0 and solve. Once we have our x value, we're plugging that x back into the, I should have been more specific, simplified function to find the y, to get a coordinate point, okay? So I'm going to go through one of these examples. Let's take B to go through, okay? First step is going to be to factor. So I'm going to factor the numerator first. This is x 6 and 1, right, over 12, 6 and 2, x squared minus 2 plus 6 minus 12, okay? All right, so this is my factored function. If I'm just looking for wholes, okay, so you're not worrying about vertical asymptotes right now. What do I see cancels? The x plus 6. That's what canceled. Okay. I've got my simplified function as f of x equals this. Okay. But again, to find my whole, I'm setting my canceled factor. Now, it only happened once, but if more than one cancels, then you have more than one whole equal to 0, and I'm solving. So this is my x coordinate, but again, I need my y coordinate as well. So I'm going to find f of negative 6 in my simplified function. And so I would say we've got a whole right there, and you can write it as a coordinate point, like negative 6, 5, 7. Alrighty, guys. You are all set to do the last set of practice problems. Good luck, and rest and relax for the rest of break.